Okay, so, now this is number 6 on the quiz that I had you discuss. Your source gives up 5 joules of energy starting at x equals x1. Gives up energy to a cart. For example, you've got a magnet system, one magnet attached to the cart, another magnet repelling it, you release it, and from here to here, well, from here on to forever, the magnetic force does 5 joules of work. Okay? Now, that's at position x1. If you start at position x2, which is further, the greater separation of the magnets, you get 2 joules from here to forever. So how many do you get from here to here? It should be obvious that that's 3 joules. Okay? So 5 joules from x1 to infinity, 2 joules from x2 to infinity. And 3 joules from x1 to x2. And that allows you to say, well, your 1/2 mv squared equals your kinetic energy. And that's 3 joules. Since you're given the mass and you found the kinetic energy, you can easily solve for velocity. And I'm not going to do that. Your algebra was up to that 5 years ago. Okay? So, -4 centimeters per second at x1. What's the velocity at x2? Well, and from x1 to x2, it does negative 3 joules of work. It does 3 joules from x1 to x2. It does negative 3 joules in the opposite direction because the forces are going to be the same in both directions. Well, that's going to be really important in the chapter that's coming up, and really a lot of this is anticipating the concepts and ideas that you're going to need in chapter 7. You're going to have an assignment from chapter 7 due, okay? Also reinforcing what you need to be learning in chapter 6. Okay, so from x2 to x1, system does negative 3 joules of work. We know the kinetic energy at x1. Well, it's not given, but we're given the velocity. Okay? So we easily calculate it, so I'm going to regard that as known, since it's just 1/2 mv squared. So I'm going to say that easily find the kinetic energy at x2 because of this. It's going to lose 3 joules of energy. Okay? 3 joules of kinetic energy in this case. And we easily find the velocity. If instead of doing a bunch of calculations more or less aimlessly, which is not a bad strategy if you can't do anything else. But don't start with a bunch of aimless calculations. Start with the overview and try to get everything into the context of what's really going on. Okay? Now, if you can't do that, then cast around for formulas, do anything you need to, and then think about what you could have done, okay? Or on a test, you know, you're desperate, you want some points, so you start doing something, and you hope I like it, okay? Okay, well, there it is. Okay, so, that's number 6.